Welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In this episode, we'll explore content delivery networks, often called CDNs, and edge security. These technologies are essential for supporting modern digital services by increasing speed, improving availability, and enhancing security. As systems and users become more distributed, relying on centralized infrastructure becomes a bottleneck and a risk. That's why understanding how CDNs and edge defenses operate is critical to securing scalable, high-performance environments. Whether you're delivering web applications, media content, or application services, the perimeter has shifted, and with it, our approach to security must evolve. Let's begin by understanding content delivery networks. A CDN is a globally distributed network of proxy servers and data centers that deliver content to users based on their geographic location. The primary purpose of a CDN is to reduce latency. When a user tries to access a website or application, the request is routed to a nearby edge server instead of a distant origin server. This results in faster load times and a more responsive experience. In addition to performance, CDNs improve availability. They provide redundancy, load balancing, and failover capabilities. When a server fails or is overloaded, traffic can be rerouted to another nearby node. CDNs also enhance scalability. When a product launch or viral event causes a sudden surge in traffic, the distributed architecture can absorb and distribute that load efficiently. Another critical advantage is that CDNs can mitigate distributed denial of service, also known as DDoS, attacks. Because traffic is spread across a wide infrastructure, malicious requests are absorbed and filtered before they reach the origin server. CDNs are essential for organizations with global audiences, complex media content, or high availability requirements. They serve as both a performance enabler and a security layer when implemented and configured correctly. Let's now look at the security considerations surrounding CDNs. While CDNs offer many benefits, they also present unique security challenges. One key issue is that the infrastructure is shared and often operated by third parties. This creates a trust relationship that must be managed carefully. Misconfigurations can expose sensitive data. If access control settings, caching policies, or authentication mechanisms are not properly defined, attackers may retrieve content that should be restricted. Another risk is that edge servers can be targeted by attackers. These nodes serve dynamic and static content, and if compromised, they can be manipulated to serve malicious code or redirect users to phishing sites. CDNs must be secured through encryption. All traffic should be protected using secure socket layer or transport layer security protocols, commonly referred to as SSL or TLS. This ensures that data in transit remains confidential and tamper-proof. Authentication to the management interfaces must also be strong. Use multi-factor authentication, enforce role-based access control, and audit all changes to configurations or deployment pipelines. Lastly, monitoring is vital. Attackers often probe edge nodes for vulnerabilities. Real-time monitoring helps detect abnormal behavior, identify performance issues, and prevent security incidents before they reach the core infrastructure. Now let's transition to the concept of edge security. Edge security refers to protecting data, applications, and infrastructure at or near the point of user interaction. Instead of sending every request to a central location, modern architectures handle processing and threat detection at the edge. This shift is important for several reasons. First, it improves performance. If a malicious request is blocked at the edge, it does not consume resources on core systems. Second, it reduces the window for attack. By detecting threats close to their source, response time is faster. Edge security includes technologies like web application firewalls, known as WAFs, reverse proxies, secure DNS filtering, and endpoint threat protection. These components monitor and inspect traffic as it enters the network, applying filters, pattern matching, and behavior analysis to identify threats. Another benefit of edge security is resilience. If core systems are offline or under attack, edge systems can continue to serve cached content, enforce policies, and maintain a layer of protection. As organizations adopt cloud net-based designs, edge computing, and distributed workloads, securing the edge becomes a fundamental pillar of cybersecurity strategy. For more information on CISSP certification and other valuable cybersecurity education resources, please visit cyberdots.me. You'll find best-selling books, training tools, and resources tailored specifically for cybersecurity professionals. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Let's now talk about how to implement effective CDN and edge security practices. Start with documentation. Clearly define how your organization uses CDNs, which content is delivered, how authentication is handled, and what monitoring tools are in place. Secure your configurations, disable directory indexing, enforce HTTPS redirects, and apply cache control headers appropriately. Use signed URLs or tokens for time-limited access to sensitive content. Employ encryption everywhere. Traffic between users and edge servers should be encrypted. So should traffic between edge nodes and the origin server. Implement strong authentication and authorization. For edge management interfaces, use identity providers with multi-factor authentication and fine-grained access controls. Monitor edge traffic continuously. Use behavior analytics to detect anomalies. Watch for unexpected geographies, excessive request volumes, or suspicious payload. Audit your vendors. If your CDN provider is a third-party service, ensure they meet your security and compliance requirements. This includes their patch management, DDoS protections, and incident response procedures. Conduct regular vulnerability assessments. Test for weak configurations, software vulnerabilities, and misapplied policies on your edge infrastructure. Combine automated scans with manual testing for full coverage. Let's now explore continuous improvement in CDN and edge security. This is not a set-and-forget environment. Threats change, content changes, vendors update their platforms. Start by regularly reviewing your configurations. Are they aligned with your current threat model? Are caching and access policies still appropriate? Analyze incidents and performance data. If a breach or outage occurs, perform a root cause analysis. If you observe slowdowns or frequent false positives from a WAF, adjust your settings. Gather feedback from multiple teams. Your network team may spot latency issues. Developers may encounter unexpected behavior during deployments. Security analysts may see gaps in monitoring. Train your staff regularly. This includes platform training for security administrators, secure content practices for developers, and awareness sessions for help desk teams who may receive user complaints. Lastly, track your metrics. Measure content delivery performance, threat detection times, uptime statistics, and the volume of blocked malicious requests. Use this data to prioritize investments and guide improvement efforts. Thank you for joining the CISSP Prepcast by Bare Metal Cyber. Visit baremetalcyber.com for additional episodes, comprehensive CISSP study resources, and personalized certification support. Deepen your understanding of content delivery networks and edge security, and will consistently support your journey toward CISSP certification success.